Okay, so in this video, I want to give you a template for how to prove that a function is injective, because we'll be doing this a number of times throughout the semester. And so to start, what I'm going to do is copy and paste the code from the previous video over into a new file called discrete math. Let's see what I call this. Discrete math injectivity proof template.tech. Okay, doesn't really matter what I called it. I just wanted to have a new file. And what I'm going to do now is delete everything that was in my document. Okay. And what I'm going to do is I'm going to just create a function. Let's say let f be a function from math blackboard z to math blackboard z, be defined by f of x equals 3x plus 7, let's say, making up a random function. And what are you upset about? Math Blackboard Bold. It doesn't like Math Blackboard Bold, and so I bet I need to use AMS symbols. And now it's happy. Okay, so to do that Blackboard Bold Z there, do Math Blackboard Bold Z. And of course, I've shown you how to define commands. One of the commands that I typically do is just do a new command /ZZ, because I get tired of typing Blackboard Bold Z. Okay. And I might do the same thing for the reals. Um, these are common things. And I might do the same thing for complex numbers. And lastly, the natural numbers. Those are some of the common commands I'll use. And I got distracted already. We will prove this. So we will prove that F is injective. Okay. And so the standard proof technique for showing that a function is injective is you can assume that f of A equals f of B. There's some elements A and B and the integers, and show that in fact A has to equal B. So what you're doing here is you're trying to show that if ever there are two values going to the same output, f of A equals f of B, then in fact A and B had to be equal. So that's the standard template. Maybe I'll do a no indent text BF around the template. It's going to be outline of the idea. And I'll move that up above. Okay. So there, a template, assume, recompile. Okay. Maybe I should give this a title here. So huge uh, discrete math uh, injectivity proof template. See how that looks. Too big. I'll make it huge. And I'll do a begin center, end center just to center that. And let's give it a color. Text, color, blue. See how that looks. That looks pretty good. Discrete math injectivity proof template. So the template is assume f of A equals f of B for some pairs A and B and Z, and show in fact that A had to be equal B. Okay, so that's the goal. Maybe I'll do a no indent here and give it a V space. Just to make it stand out just a little bit. That's too far. I'll do 12 point. There's your vertical space. Okay, that's the goal. Prove that F is injective. So again, what we're going to do is say, begin. I don't know if I can do this yet. Proof, end proof. Do I have the right packages for that to work? No. I wonder if I can get by with just AMS theorem. Yeah, okay. So notice that if you have AMS theorem loaded as a package, then when you do begin proof, end proof, it automatically starts with proof of what you're about to show, and it puts a QED symbol at the very end. Um, Notice you can also just get that to show up if you do slash QED. That'll also make that box there, but I like using this predefined template. Okay, so we are going to assume that there exists A and B elements of the integers such that f of A equals f of B. And then we're going to do some math. And at the very end, we're going to say, we're going to hopefully conclude that hence A equals B. So we suppose that there were two different numbers mapping to the same output, and then show that they in fact were the same number mapping to the same output. So every output has exactly one input. That's the idea of a one-to-one function. Of course, this is what I have to fill in is what I've called text colored math with this command. So recompile. Okay, so we have our first statement. That's kind of the boundary of our proof puzzle here. The border of it is we typically always just assume if you have an injectivity proof that there exists A and B such that f of A equals f of B. And then we do some math and we end with hence A equals B. And then we can conclude, therefore, F is injective. Yeah. That seems like a lot of work, but you're going to see that like we get to just use this template over and over and over again. And so if you have this LaTeX code, you can just fill in the dots here for literally what this math dots is. And how do we fill in the math dots? Well, the only thing we really have to work with right now is the definition of f of x. So that's the next thing I'm going to do is I'm going to say begin a line, end a line. A line is just an environment that allows you to line up several equations in a row. I'll show you how to do that in a second. But right now I'm just going to say f of A is 3 times A plus 7. And that is equal to 3 times B plus 7, which is the definition of f of B. Okay, so that's what I had to work with so far. Maybe I'll line them up there. And it's not going to be clear why there's an ampersand there quite yet, but there will be in a second. So what I'm going to do is copy this down again. I have 3A plus 7 ampersand equals 3B plus 7. And now plus not 7y plus 7, recompile. Okay. So the ampersand just says line these things up. So I'm lining up these two equal signs there. So this is what I was given, right? F of A equals F of B. So therefore, F of A is 3A plus 7. It has to be equal to 3B plus 7, which is F of B. And now I'm going to do some math here. So let's see here. What can I do? I could get to 3A equals 3B. And how did I get there? Well, I subtracted 7 from both sides. So I'm going to type that in text. Subtract 7 from both sides. The equation, well, just both sides for now. And this also has to be in text. Because I'm in align mode, which is in math mode. And so if I don't put that in text, then it's going to be all italicized and look ugly, not have spaces. So subtract 7 from both sides. That's how I got from here to there, okay? So there's a justification. Hopefully it's clear how you get from here to here. And now to get from there to A equals B, I'm just gonna say that for my justification, in parentheses, text, divide both sides by 3, or maybe I should say multiply both sides of the equation by 1/3. Be another way of writing that. Fraction 1/3. I haven't told you already in these video series to make a fraction you could do 1/3 like that, but that's kind of ugly. So you could do a fraction slash frac, the numerator and the squiggly brackets, and then denominator in the second squiggly brackets, and that'll do a fraction like this, right there, by 1/3. And now that looks kind of ugly because the parentheses are not as big as the 1/3. So what I'm going to do is do a left parenthesis and a right parenthesis. And that should make the parentheses big enough. There you go. Nice. Okay. And now this is just ugly because A equals B is shifted over here, and that's because I didn't align the equal signs. So I just need to put an ampersand before that equal sign, and now I have a nicely aligned equation array, environment array. Okay, so we got what we wanted. We did some math. Maybe I'll make this all in one color, text color blue. But we did this math in blue here. And this is a good proof template where you'll do some math, but then on the side, you'll have explanations of each line. So hopefully it's clear how you go from here to there, to there, to there. And it's explaining, this piece here is explaining how you went from this line to the next line and this line to the next line. And maybe it would be better if I move those down, actually. So this is the explanation for how you get to that line. And this is how you get from line, what? If this is line 1, 2, 3, 4, maybe I should do that. Hold on. Let me show you this. You don't do the asterisk in the align environment. Then you get a numbered list of equations. So now I could say to get from line 2 to 3, we subtract 7 from both sides. And to get from line 3 to 4, we divide both sides by 3. Okay, so this is how you would write up a proof that this function f of x equals 3x plus 7 is injective, using LaTeX and just being as rigorous as possible, explaining every step of the line. Okay, so now you try. I got a second example for you to try, and I'll put the answer in the code that I share later. You try this one, right? F of x is, I don't know, fraction 1/2 or 1/3 x minus pi. Yeah, I don't know if I want to do pi. Let's do a discrete integer 2. Yeah. So do this. Show that this function is injective, and try to just copy and paste this proof template and pause my video, and then at the very end you can check your answer. Okay. So this is the beauty of LaTeX, is that once you have this template, it's a lot of copy and paste, of course. Maybe I should have kept all that aligned there too. So I'll even keep them blue here. Maybe I'll make this argument red. So I got to delete that piece and that piece. But some of this I might be able to reuse. So that and that, and then I'll compile and see what it's like. So, and line those up with the ampersand so it's a little prettier in the code. Okay, so we got something like this. Now in this case, f of a is going to be fraction 1/3 x, 1/3 x minus 2. Instead of x, I'm going to have a there. And I'm going to copy and paste it and put B there. Okay. And then maybe I'll just copy and paste that again without the F of A, F of B. Okay. So same sort of setup here. I got, basically I'm just rewriting F of A and F of B without the F of A and F of B at this point. And now what I want to do is simplify this down to A equals B. So the first thing I would do is add two to both sides. So in text, add to text to both sides. So there's an explanation, add two to both sides. Again, don't want the space there, or there. Okay, that looks kind of nice. And I don't really need, oh, I'll leave the lines for now. So add two to both sides. I actually didn't do that yet. Paste this in and just add two. So of course, for demonstration purposes, maybe I'll add two and subtract two at the same time. Of course, I can simplify. Negative 2 plus 2 is 0. So get rid of those. Now I have 1/3 A equals 1/3 B. And so now to get from line 7 to line 8, I'm going to multiply text. Multiply by 3. Okay. Hence, we conclude that A equals B, therefore F is injective. So that's just a quick preview on how you would show a function's injective. I'm sure this will be on a test, so you guys better study it up. Have a great night. Take care. Bye.